gonna be, oh my gosh, this takes me so long. I'm gonna do that. It's gonna be similar to properties of addition with a couple little changes. So we're gonna start with the commutative property. We know that in the commutative property for addition, A plus B, so any number plus another number is equal to that other number plus your first number. So saying the order doesn't matter. So for the commutative property, if we had the numbers 7 times 8, what is 7 times 8? I know that 7 times 8 is 56.
I always forget that one.
That's like the only one I remember, Mr. Ronkin, because 5, 6, 7, 8. See, you know?
It's a good tip.
I know as well that 8 times 7 is also 56. So I can write the equation 7 times 8 equals 8 times 7, and that proves that both these sides are equal and the order doesn't matter. All right, now moving on to the associative property. The associative property just changes the grouping. You can change the order, but as we know for order of operations, parentheses means you start with it. So the associative property says that if you change the starting point, you will still get the same answer for multiplication and addition. All right, so if we're going back to just plain variables to represent any number, we would say A, we're going to do a plus, A plus B plus C equals A in parentheses plus B plus C. So that's saying if I start with these two numbers, or if I start with these two numbers, I'm still going to get the same sum. For multiplication, it will look something like this. We'll do 3 times, what did I do? 2 times 4. 2 times 4 first. And then we'll see if it equals, parentheses, 3 times 2 times 4. So order of operations says I start with the parentheses. 2 times 4 is 8, times 3 is 24. This side, 3 times 2 is 6, 6 times 4 is 24. So this equation proves that it's correct. So remember, associative isn't the order, it's the grouping. So if you see parentheses and the grouping of the parentheses changes, think associative. All right, identity is different than addition. In addition, we add 0, but in multiplication, we take a number times 1 equals that number. All right, so if I had the example of 108 times 1, my answer will be 108. All right, last one we're going to do is the distributive property. Okay, this one's kind of confusing. So if we have the distributive property, I'm going to just start with an equation to begin with. 5 times 8 plus 6. So there are a couple ways that I could solve this. If I follow this, I could add these two together and then multiply, but I can also separate it into 2 problems instead of multiplying 8 times 14. Okay, because 8 plus 6 is 14. I could do that, but the distributive property tells me that I can rewrite this into 2 problems. I can write the 5 times 8 plus, because the 8 and the 6 are connected by a plus, plus 5 times 6. And see if I get the same answer. So now I'm going to solve, I'm just going to break it so it's clear. I'm going to solve this side, and then I'll solve this side to see if we get the same answer. 8 plus 6, like I told you before, is 14. 5 times 14, I'm going to solve that over here. 4 times 5 is 20. 70 is what I got here. All right, 5 times 8 is 40, plus 5 times 6, which is 30. 40 plus 30 is 70. So the distributive property says you can turn one problem into 2 problems, or, yeah, it's basically breaking up more complicated multiplication problems or addition problems into smaller ones.
Awesome, Miss Walsh. Thank you.